Hi guys, so now we're ready to talk about stoichiometry, but before we even get into different types of calculations, the first thing, I know it's kind of basic, but the first thing we have to look at is balancing reactions. So why do we even care about balancing reactions? Well, it's because it's just the first thing that we need to do before the stoichiometry can be analyzed. Pretty much, we need to be able to know how to balance a reaction in order to do any calculations that we'll see later on, like looking at what is the limiting reagent, what is the percent yield, and stuff like that. So what exactly makes a reaction balanced? So if we're given a chemical reaction shown below, so we see that we have an unbalanced chemical reaction, what we're checking for to see if it's balanced is we're going to count the number of each type of atom on the left side or the reactant side. So the number of atoms of each type, so for example, oxygen atoms on the reactant side must equal the number of atoms of each type on the product side. So we know it's balanced when we have the exact same number of atoms of each type on each side of the arrow. So for example, we'll have 2 oxygen atoms on the left side and 2 on the right side. We'll have maybe 3 carbon atoms on the left side, 3 carbon on the right side. So the numbers don't matter as long as we have the same number of each atom on opposite sides of the arrow. So if I wanted to balance this chemical reaction, I know this is a more simpler example, but let's just say we want to start with carbon. So on the left side, we see that there are right now 3 carbon atoms. That's indicated by that subscript. And on the right side, there is an invisible subscript, so we can just say that there's 1 carbon atom. So then I know I would have to multiply the right side by 3. So I put a 3 there to get 3 carbons on the right side. Now for hydrogen, I see that there are 8 hydrogens on the left and only 2 on the right. So I would need to multiply by 4 now on the right, so that I'm now doing 4 times 2 to get 8, and I have 8 hydrogens on the left. Okay, so next we can go to oxygen. So on the left, I see that there are 2 oxygens. On the right, we actually have to do 3 times 2, so 6 oxygens plus these 4. So that's a total of 10 oxygens now on the right, and there's only 2 on the left. So in order to get the same number of oxygen atoms on each side, I'd want to multiply this one by 5. So now I know that it's balanced because we have the same number of each atom on both sides. So on the left side, we have 3 carbons. On the right side, we have 3 carbons. So I'm pretty much doing a check at the same time. On the left side, I have 8 hydrogens. On the right side, I also have 8 hydrogens. And on the left side, I have 10 oxygen atoms. And on the right side, I also have 10 oxygen atoms. So that's how we know that we for sure balanced the equation.